Hi, I'm Nadia Nadesan, also another Nadia at AIxD, and I was the research lead for Small AI. So if you need to download Python or do any of the workshop prep, please feel free to do so while I'm speaking. I'm going to give a little bit of the theoretical background of what went into Small AI. So I make the argument that has been made by very, very many scholars that AI is neither artificial nor intelligent, and I really like the work by this academic named Shuang Frost, who highlights that how the phrase AI is said is different in different languages. For example, she highlights that artificial intelligence in Chinese was originally introduced via Japan. The actual English translation is human-made intelligence. And so these trees right here, so my family is from Malaysia. These are actually rubber trees. Rubber trees were used to lay the first telegram lines in the early 1900s. And the rubber that they sourced actually came from Malaysia. They cut down these trees to near extinction to lay the telegram lines that now define where our internet cables are laid today. So this is to say that there is material and human force behind what we think of as AI. I encourage people to think of what kind of intelligence do we see in AI. There's so many kinds of intelligence. There's naturalist intelligence, musical intelligence, computational intelligence that we often think of when we think of artificial intelligence, existential intelligence, interpersonal intelligence, bodily kinesthetic intelligence. So what kind of intelligence is driving progress, how we see progress and how we see artificial intelligence? It's just a provocation, honestly. And today, AI is far from being conscious, but it is worth thinking about what types of intelligence are being prioritized. After all, the intelligence we prioritize in our machines likely lines up with the intelligence that we prioritize in our societies. And so this is a little bit about if AI can learn. I really want to establish that AI, like ChatGPT, makes more probably right answers. Eliza is AI's great-grandmother, and she used a different kind of heuristic logic where phrases were matched with certain responses. But the creator, Joseph Weizenbaum, thought that this was incredibly problematic in terms of thinking of whether or not machines could ever be intelligent. And this is an illustration of all the people, things, places, and materials that go into building AI. But we are here for small AI. So small AI, when developing it, there were three main themes that I felt that I surfaced in my work. First was nature as a feature. So in this presentation, I showed you the rubber trees, maps and cartographies about the production of AI, and thinking about nature as a mainstay of when thinking about how we conceptualize and create technologies versus a footnote. For example, what if we thought about the impact on climate versus as a main principle of our design versus an afterthought of, okay, the world is warming. And then the other one is placefulness. A lot of my research looks into AI governance, which is how do everyday people reclaim agency and how AI is made and how AI policy is created. So how do we create a sense of placefulness when creating this technology, i.e. the people, the culture, the politics, the economies of a place that are just as important when we think about how we create our technologies and also not an afterthought, and also towards process. In the process of this research, I often thought that the process of making AI was just as interesting or as innovative as the end product itself. And so one of the examples I have for moving with nature is this island in Assam. So what I thought was really interesting was that there is this island in Assam and it changes in size because of the monsoon every year. And historically, this means that one side of the river will have more land or less land depending on the monsoon. However, in the research done by this academic named Krishnan, and when she was speaking with her interlocutors, they said the problem isn't that the river changes the land size, but the problem is the borders that we have to recreate and the bureaucracy, which dictates what we gain or lose every year. And this I thought was very interesting because if borders moved fluidly, or if the ways in which we thought of what distinguished bureaucratic lines could move with rather than against nature or rather than ignoring nature in itself, that this would be an interesting paradigm shift for how we could create technology, or how we could think about moving with nature rather than against it. And then the idea of placefulness, which is against the idea of placefulness of an optimized life spent online. I want to argue for a new placefulness that yields sensitivity and responsibility to the historical, what happened here, and the ecological, who and what lives lived here. And so here I have a screenshot from the work of forensic architecture and their investigation of the murder of the journalist Scarin. I use this example because there is no cartography. I am an urbanist first and a technologist later. And for me, cartography often maps how violence was enacted on a place. And what I think is very interesting of forensic architecture is to invert this science in order to map out and provide evidence for state-backed violence across the world. They've worked in Namibia, they've worked in Gaza, to use architecture not simply to create new buildings, but to investigate and to look into something more profoundly. And so how do we use our generative sciences like AI to investigate and more profoundly understand the world around us? And then towards process. Because of my work on governance, I see where we can innovate AI in the process of making AI. How do we curate data? How do we understand how people understand data policy? How can we make this concurrent with cultural or political realities? So this is a screenshot of a project done at the Serpentine Gallery, where they created this role of data steward who would look into the interests of choir singers and when they would decide what they would do with their choral data. Essentially, for me, looking at how people participate and play a role in what their data is has always been my interest, honestly, from the start. And one of the more interesting projects I would highlight is Te Hiku Media. So Te Hiku Media was developed by the Maori people in New Zealand, and they created their own large language model with only 400 hours of spoken language. So they're given far more funding from the state of New Zealand than other Indigenous peoples to maintain the integrity and protect their culture and cultural heritage. So the reason that they only needed 400 hours of spoken language was because they pulled from their radio, television, and high quality of spoken language they had recorded. I think this is interesting because what if a facet of design was the linguistic integrity of your language model versus your language model's ability to answer any and everything? And so they also came up with the Ware Koreo Kai Tia Kitanga license, the guardianship license. This means that open is not equal for all, and they give priority to Maori peoples when accessing their data and data sets. So this is my ancestral knowledge. Polycolumns are a visual design language that comes from the, most people would say South Indian, I would say Tamil people because I'm a Tamil person. And it is one of the few instances where indigenous culture has informed Western computation versus the other way around. It contains 4 logics, which are infinity, symmetry, fractals, and array grammars. It is a design you do in front of your home. The idea is that you generate good karma before your day starts by feeding 1,000 souls. So that is that it is done in drawings in rice flour in the front of your home so that ants, birds, and the like can come eat. And it's also a way to show that your home is hospitable and that everyone in your house is well. It is a design you do first thing in the morning while you are getting ready to go and start your day. But why I think this is interesting is because it is a form of embodied mathematics. It is a form of relating to the natural world. It is a form of design that has profoundly influenced computation, all at the same time in this realm of domesticity. So when we think about what technology can do at what scale and with what materials, I think this troubles the idea that you can only create this kind of innovation with large amounts of computational power, or in a lab, or in a studio, when you could also do it at home. And so this is an example of a polycolumn. And what's more interesting is that in many villages that are not electrified, you do it in the dark. It is an embodied form of mathematics because once you start drawing, you feel the logic of the design as you are doing it. And it is a really interesting thing to witness when the sun rises. And then the other project I'm going to highlight is Masakhane, which roughly translate we build together in isiZulu. The goal is for Africans to shape and own their own technological advances towards human dignity, well-being, and equity through inclusive community building and open participatory research and multidisciplinarity. So honestly, there are 27 million Igbo speakers. This means that there is not a lack of data. And there are 1 million, for example, Icelandic speakers, but Icelandic is far more represented in the realm of natural language processing. And so this project really highlights what it doesn't mean to be under-resourced and why. So this project is about creating NLP research in African languages and not just criticizing the lack of representation, but also creating autonomy and building through community. Because we think of AI as constantly expanding and affecting all services, but how can people access those services when it's not accessible in their own language? Masakhane project underscores the critical issue of missing data and the lack of geographic and linguistic diversity in natural language processing research. The disparities in available data between African languages and languages spoken in the regions with more technological resources reveal a deep imbalance. Despite the large number of speakers, like Igbo, while less widely spoken languages like Icelandic are supported, this lack of representation not only reflects a broader issue in global research priorities, but also limits the inclusivity and effectiveness of NLP systems. Addressing these gaps is essential for creating technologies that serve more equitable and linguistically diverse global community. And so an artist that I worked with during this small AI research period was Linda Duina Rebis. And she did a really lovely project called Once Upon a Garden, which also addresses what does it mean to fill in the gaps with AI. And so the project Once Upon a Garden is about the fact that there's very little data about the flora and fauna in the Sahel region. And actually, as the years pass, there will be less and less flora and fauna in this region as it will be globally. So her grandmother will have seen far more flowers than she will in her lifetime. And so this project is to look at the existing data and then create an imagined archive of what those flowers are.
What is worth remembering? I have been asking myself this question for the past few years, and the answer always led me back to my grandmother. She made room for me in the world, so that I could defy the rules and places I was confined into and be the artist I am. I always knew how important she was to me, but I only truly realized it after she was gone. What is worth remembering? Her, and her love for flowers, and the love for flowers she instilled in me day after day, as she plucked them from her mother's garden and arranged them on porcelain plates that she would lay by each window and in front of each photograph of a family member who left us. This project, Once Upon a Garden, is an archive. In this archive, what's missing reveals more than what's present. To be able to fill these gaps with synthetic memory is a unique feature and opportunity of our time. Yet the process of making synthetic memory in celebration or mourning of organic life is a problematic process. But how else do we remember what we never recorded? I found my answer, my memory machine, in a deeply human tool, flaws and all. No matter how much we insist on its artificial nature, AI is of us, our worlds, our concerns, our context, what we care to record, what we care to remember. That's fundamentally what training data means. Hard, cold electrical signals about soft, warm lives. Once Upon a Garden is an archive of critically endangered and extinct flowers that we have little to no records of, and therefore no way to remember. It is speculative because missing data is replaced with human memory and machine hallucination. Over the past few years, the same training material for this work has been re-explored using new and improved AI tools. At first, to remember better, and then to lift the veil and mourn the only way for us to remember what we didn't bother recording, because we didn't think it was worth recording then. Once Upon a Garden is my way of traveling back in time to my grandmother's garden and her mother's garden, and so on and so forth, as far as records go. Maybe someday I'll find her there.
I think what I've been trying to say for a lot of this presentation, sorry, I was a bit nervous when I started, was that AI is deeply human, and I think our deeply human communities, cultures, languages, politics need to also be reflected in how we make this technology, not so that it doesn't simply extract from the world around us, but so that it also affirms who we are and how we connect. And my favorite part of governance is protesting. So I really wanted to highlight the fact that the Hollywood strikes were really important in terms of thinking about AI governance, because it was the first time where unions really negotiated the use of their image, their data, and how it would be used in AI systems. And we have Google workers protesting with Tech Against Apartheid and Deliveroo couriers through London during a strike over pay rights and working conditions and facial bans in specific cities across the United States. Governance is not something that I think we can ignore. And I think it's really interesting that the places we live and the places we work often are the easiest places for us to reclaim what kind of AI is made and how it's used in our everyday life. So this can be work unions, this can be in schools, this can be with your city. If you want to talk to me more about it, I'm around. But this is a topic I'm deeply interested in, and I do believe that we can reclaim our agencies as actors in these systems.
Thank you. There's a quote at the end. You want to show the quote at the end?
I think we know this quote. Remember to imagine and craft the worlds you cannot live without, just as you dismantle the ones we cannot live in.
Do you want to get any questions?
Yeah, did anyone have any questions?
Yeah?
Hi. Oh, it has a microphone too.
Yeah.
I thought it just looks very cool. Thank you so much for this wonderful presentation. Really fascinating. I have a question. Maybe it's a bit ignorant, sorry, but in your speech, it seems like you're advocating for more languages to become part of natural language processing, so they're available for AI or for users to use them with AI. But I'm wondering, thinking about it the other way around, couldn't it be an advantage if your language isn't recognizable by AI? Might it be a form of protection? Because at the moment, we don't know who is owning these AI tools and who they really benefit. So if we are talking about cultural property, maybe shouldn't we wait for agency to be enforced through governance before we make everything accessible? So that would be my question. Like, yeah, what do you think?
It's a really valid question. The examples of like Te Hiku Media and Masakhane are all about those language communities owning the means of production for their natural language processing data and AI. And I guess I don't think governance is governments. I think there's so many types of small institutions, organizations that hold a lot of power in the way we work and connect and have our social lives together. And I do advocate for, like, for example, today's workshop of Leo showing us how we can like sort of do our own either DIY or more than DIY projects around how we create AI and making like this space more varied. Like, I do think it should be a spectrum of production versus in the hands of a few corporations or making your data available for a few corporations.
Yeah, makes sense. Thanks a lot.
All right. let's take a 1-2 minutes break. In the meantime, who doesn't have the tools yet? Python and a text editor. Raise your hand. 1, 2, 3, 4. Okay. I will help you in these 2 minutes. And then we start. Going onto your terminal. On Windows, it's called command prompt. On Mac, is terminal, command line interface, whatever. And you type in Python. If it gives you a version, that means you have Python. You can also try Py, Py. And if you're on Mac, it will likely be Python 3. And the other thing you will need is a text editor. I'm using Visual Studio Code, which is this one. But you can also really use Pulsar TextMate for macOS. It's quite a lightweight. Sometimes I even use the Notepad from Windows, and that's fine. Okay, I will quickly introduce myself. My name is Leo Scarin. I am an artist working with code. What I normally say is that sometimes I use code to solve my problems, to solve my installation problems. Sometimes I use it to create problems. I'm also part of RGB Dog Studio, which is a studio for convivial technology. Convivial technology is essentially technology that can be reclaimed and redesigned autonomously. So today we're going to do a very simple task, which is downloading a language model on our computer and running it. But it's not as simple to do it autonomously. We'll see that we need actually a very small language model, because the language models, the large language models that are out there, are too heavy to download on your old computers, or the Wi-Fi is too slow. So we're going to go small. And we're going to see also why downloading a language model on our computer makes us more autonomous in the way we interface with the language model. So normally something like ChatGPT is just conversational. There's no way around it. But there are other ways that language models would work. And so we're going to work with the auto-completion. Like we're going to have a language model complete our sentences. And you can do many other things, like you can use time-based tasks. You can tell your computer to only run at 11 in the evening before you go to bed, or you can run it using prompts that you scrape from the internet. Then you have more creative freedom on how you interface with a language model. A little example, I have a parrot at the entrance that is trained on my gossip. For a month last year, I documented my gossip. It was a bit awkward because I had to actually take my microphone out whenever I would talk to a friend about gossipy stuff, with consent, of course. And then I transcribed all the gossip. I fine-tuned it. I basically used a small language model, and I trained basically it on my gossip. And then I ran a little text-to-speech app. And if you go at the entrance, the parrot is generating new gossip. It's mostly about art institutions, fundings, and art academies. So it might be boring if you're not into it, but that's mostly what my gossip was about. And it's a parrot as a reference to the danger of stochastic parrot, which is a term coined in the famous paper on the danger of stochastic parrots. Let's begin. So the first thing we want to do is open our terminal. So we're going to communicate with our computer in a way that maybe some of you have not done before. For Mac, it's command space. For Windows, you just go to the search bar and you look for your command prompt. It is a text-based way of talking to your computer. Normally, you have your mouse, right? You click around, you go to your folders right here. You can do that also on the terminal by giving commands to your computer. So my command would be change directory, cd. You can also do this yourself on Mac. And I'm going to go to my desktop. If you don't know actually where you are in here, because it doesn't give you any graphic interface, you can just type dir for Windows or ls for Mac. And it gives you a list of folders. And I want to go right here. So I'm going to say change directory, desktop. Now I'm in my desktop. So we can change directory. We can go into folders. We can also create folders. This also varies between Mac and Windows. It's MD, but it could also be MKDIR. So MD stands for make directory, or MKDIR, make directory. And I'm going to type the name of my new folder, which will be slow AI. So that is indicating where you are right now. Yeah, that is your address. When I open the terminal, it automatically sends me to Scars is just my nickname, my username. You probably have your own. And then from there, you can navigate to your desktop. I have this slow AI folder, but I don't see it yet. So I'm going to print my directory again. And it's right there. If I go to my desktop, here's the folder I just created. Also, I will ask you a big favor. If you're already a bit tech savvy, find someone that is not tech savvy next to you and help them out. That will make the process very faster. If you're not tech savvy, find someone that's tech savvy next to you. It's also a good excuse to start talking to other people around. So now we have our folder in there. We want to navigate into our folder. So I'm going to say cd small AI. Was it small AI? Slow AI. Yeah. I mean, you can really call it whatever you want. This is how I call my folder, slow AI. And now I'm in. You can tell you're in because now your address is up until that folder. Okay. Now we're going to demonstrate a few things you can do with terminal. You don't have to follow along because we're not going to use this later. But just so you know, you can also create files. So I can say echo, and I'm going to say, this is a note I'm leaving to you, Leo, from the menders of my memory. Don't forget me. And I'm going to call it note.txt. And now, in my folder, I have a note. And I can also read the note from my terminal. I can say type note.txt. And that gives me the note. I can also create other types of files. For example, I can create my Python script. I'm going to call it my main Python script. And I just do like this. Echo is a command that creates files. And I'm just going to run it with this more than symbol, which will define the name of my file. Now, you don't have to do this. You can also just go into your text editor, create a new file. So there are many ways to do things with your computer, and that's why it's so beautiful. MKDIR. Like this. So make directory. All right, now I think we're kind of done with the terminal. Yeah, we're kind of done with the terminal. Let's go to the text editor. So let's introduce ourselves to the text editor. I'm going to create a new file from my own text editor. You can use your own. I'm going to say Visual Studio Code. By the way, with this, you can also open programs. I want to open my notepad, which is an executable file. I type in notepad.exe, and that's my notepad. And then here I can type, this is a reminder to read the note. I'm going to save it in my folder right here. Reminder. And now we can type reminder.txt. So it's a reminder to read the note. So let's read the note. Notepad, we can also use it as a text editor. Of course, it's not the best way to do things because it doesn't have all the colors that you want when you code, but you can also do it from here. So I'm going to go to my other code editor, Visual Studio Code. I'm gonna run a new file. I'm gonna actually open my folder here, Slow AI, and I'm gonna work in that folder. You can do this with most code editors. So that's the file I just created, but I'm gonna redo that to recycle bin. And I'm gonna call it main.py. So that will be our main script. And now you can type things again, but suddenly some words will be colored, like when you import something or when you run a function, it will have this yellow color. Let me make it a bit bigger. Or when you declare a variable. So I'm going to say print using the print function. And then in my print function, I'm going to quote unquote, this is a memo to read the reminder. So just one function, one line, print, round brackets, that indicates that this is a function. This is functional to your computer. Your computer knows that when you say print, it will display something, mostly text or numbers. And then you put it in quotes because it's a sentence. Now I go back to my terminal and making sure that I have my main py here. I'm going to run it. And to run it, you need to tell it, open it with Python. So you're going to say Python space or Python 3 for Mac users or Py for other people that prefer shortcut. Main.py. If I run that, it prints my memo to read the reminder, which I'm going to read right now. What's next? Maybe we can say that I want to print this at a particular time of the day, let's say 10:47. So I'm going to say if, I'm going to run an if statement, if time, no, I actually don't know how to do that. Let's do like this. Let's do it simpler. So I'm going to print this and I'm going to say time.sleep for like 2 seconds. I'm going to make my computer just wait for 2 seconds. And then I'm going to send another note. Did you read the note yet? And if I run this, Python main.py, it will not work because it says that the time is not defined. It doesn't know what time is. So computers are extremely stupid. You need to explain to them everything, including what time is. So for Python, we have what we call a library. A library is sort of a package with already made functions and vocabularies to understand specific tasks. In our case, we want to import time. So this is how it would look. Import time. And now we know what time is. And if I run this on my terminal, it's sending me the memo and then the note. I'm going to do it again. 1, 2, ta-da. So we can play with time now. It's so exciting. Okay, so some common errors. Save your file before running it. If it's empty, it won't run. If Python doesn't work, you can try Python 3 or just py. And then the name of the file. Another common error is that you're not in the right folder. So make sure that your file is in the folder that you're accessing. Now, let's move on to the language model thingy. So we're going to use Python. We're going to import libraries that allow us to know what a language model is, because computer doesn't know yet. And then we're going to run a few functions similar to this. But before that, let's see what libraries and tools we're going to use. So what I use mostly is Hugging Face. It's a platform owned by some French-American company. And they started just making a chatbot, then it evolved into this platform where people upload their models, their data sets. There's a lot of stuff in here. So if you go to huggingface.co company, this is the main page. And you don't need to register, but you can already browse through models, datasets. So you have datasets over here. There's many different datasets. You have the models. In datasets, for example, I think you might be able to see the Wikipedia datasets over here. Wikipedia. In models, that's where we're going to go. That's where we're going to kind of browse. And already see that there are so many models that you can use, but some of them are too heavy. On the left side, you see that there are multimodal, there are computer vision. We don't need that. You have natural language processing, which is our field today. And within natural language processing, we also have many different types of models, but what we need is the text generation. So in huggingface.co, I go to models, and then I go scroll down, text generation, and that will filter for me already only the text generation models. And it's, wow, Microsoft, Google, okay. We have DeepSeek, for example. We can use the DeepSeek model. However, if we do that, I just open it, right? This is how it looks. This is a 685 billion parameters. So it's quite a heavy one. If you go to files and version, you can see that this save tensors, which is basically the file that holds the model, it's gigabytes and gigabytes and gigabytes and gigabytes and gigabytes and gigabytes and more. So don't have time today to do this. I don't even have that much gigabytes in my computer. I think I have like very little. So instead of that, we're going to use a small one. We're going to use something that's called Distill GPT. It's what I use for my Parrot. It's a tiny language model, and it uses Distill. So I'm going to explain in a second what GPT means and Distill, but you can type in here Distill GPT, and it's from Distill Bird. And the second one, GPT-2. So if you open that up, this is the profile of Distill GPT-2. I want to do a little exercise actually to get out of your screen for a second. So I will need 10 volunteers here. This table can come here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can line up. All right, I'm going to make a little embodied exercise to explain what the difference is between GPT and other types of models. So the GPT is a generative pre-trained transformer, not like the big machines, but it's the name of the model. Before transformers, we have other models like the recursive neural networks, sequential models. So I'll show you what a sequential model works like. I'm going to give you a pair of words. Don't look at each other's. Here. This for you. I need a 10th. All right, so now, one by one, you're going to choose a word. You're going to say to the next person. You're going to choose a word based on that, and you're going to say your word only to the next person. Is that clear? You whisper, yeah, nobody else hears. So you just say the word, and then you choose your own word based on that, and then you say your word to the next person. Yeah.
We need to.
Between the two, yeah. Let's go. So this is a sequence, right? So in recursive neural networks, tokens, so basically pieces of words, do not know about the whole sentence, but they are informed about the previous one, and they complete the sentence by doing that. All right, now if we can say it out loud, word by word. The curious child walked across the dark forest, joyfully wept. Okay. Funny. So that's the sentence we created. Now I'm going to do the same exercise, but now I'm going to give you stickers. You're going to put all of them on the ground. Maybe you can try on the ground. So you're going to see each other's words, and you're going to give a sticker to the word that you think interests you the most to each one. So, for example, say I have this word here. which is walked or paused. I go to U, and you have A and D, and I give you a sticker on D, because that looks the most, or it's the one that I'm interested to the most. This is the one I give more attention to. Yeah, and we do this for each. Yeah, it'll be a bit messy. Here we have stickers, so feel free to grab some here. Ideally, you want to do all here. Yeah, and there is no order here. It's all randomic, non-linear here. So just give a sticker to the word that you are giving more attention to based on your own words. No words. It's just a sticker. Yeah, they're voting each other's. So transformers have a way of working that uses self-attention. So they read the full sentence basically at once, and then for each token, they give some sort of weight. Like, this is the word that relates most to my word, and then it all happens at once. So now it's very messy. They're all looking at each other's words, all of these tokens going around. They're not sequenced linearly. It will be sequenced at the end because I gave them an order. There's 1, 2, 3, 4, 5. But that's how transformers work. Well, again, this is a model, right, of language models. This is not accurate, but also language models are models of language. So we're making models of a language model. But it's to give an understanding of what the difference is between recursive neural networks, transformers, and then GPT. Even further, it's a development of a transformer architecture. So these are all architectures of language models. Okay, we can pause. Now you go back to your order, and you're gonna say out loud the word that has the most votes. The curious traveler walked across my dark ocean joyfully, laughed. So my curious traveler walked across my ocean, joyfully laughed. Yeah, that's beautiful. Okay, thank you. You can go back to your places. Thanks. So this is in no way better or worse, but each architecture has a different purpose. And in our case, to complete a sentence, if it's a short sentence, we don't need GPT. We don't need this whole big architectures, because also they need just more attention. Their mind was working much more, looking around and choosing and voting. But for longer sentences, maybe this is a better way. So it really depends on your case. In our case, we're using a distilled version of GPT. What is distilled? Distilled is if I gave you 10 words and you already know the result and you try to imitate the result. So you don't need that much mental work. It's faster. It's smaller. That's distilled GPT. So how do we download this? Hugging Face has a library. It's very famous for this library. It's called Transformers, which is also the architecture of the language model. And to use it in Python, you want to import Transformer. You also want to install it in your computer from your terminal. We'll see how to do that. But first of all, we're going to copy these two. So I'm just going to press on the copy icon. And I'm going to go back to Python. I can remove all this. And just going to place it here for now. So that's the model we're going to use. It's called distillbert/distillgpt2. Now we need to import our library transformers. Right here, we're going to say import transformers. That's the first step. And actually, we're not using just transformers, but we're using something that is called pipeline. The pipelines are a great and easy way to use models for inference. So this is something you can use to just run the model in your computer to run sentences, basically. Inference is the process where you have your model trained, everything's done, you just give it a sentence and respond to it. And it is as easy as running this. well, more like this. So you will put your model in a function and then you will run prompt. So we go back to our Python and we want to use the pipeline function, which is pipeline with round brackets. And in the function, we're going to define what our model does and what the model is. So we're doing text generation. Remember, we filtered through all the different types of models. So I'm going to open quotes. Make sure you open the quotes because otherwise it doesn't know what you're saying. Text minus generation, dash minus. And then comma. And then open quotes again. You need to say model equal, open quotes, and then you can copy the model inside the quotes. So your first line will look like this. Pipeline, open the round brackets. So we're using a pipeline function. We're going to do something with this pipeline. We're using a text generator. So text generation, model, distill GPT-2. And because we're using pipeline, we're not only importing transformers, but we're importing pipelines. So we say from transformers, import pipeline. We have to change the first line a bit. Okay. And now this doesn't do anything yet because we're not running any prompt, but also because we say import transformers and pipeline, but Python doesn't know where in your computer to find them. And actually you don't have that in your computer yet. So we need to go back to the terminal and install it. So before running anything, we go back to our terminal and we're going to install those libraries. And we're not going to install them in your computer. We're going to install them in a specific folder. So then you can get rid of it once you're done. We're going to create what is called a virtual environment. A virtual environment is this tiny folder which contains all the libraries, commands that Python needs when it runs transformers or other scripts. So how to create a virtual environment? You run a Python or Python 3 space -m, because we're using a module of Python. And remember to use the dash. And then we're going to say venv. So that's the virtual environment. V stands for virtual and environment. And then we're going to give it a name to our folder. So I'm going to call it env. Simple. You can also call it small env or Juanito. I'm going to call it env. So again, Python or Python 3 -m venv env. We press enter. If nothing happens, it's a good sign. So again, it only works if you spell all of these commands all at once. If you just do Python or just Python venv, it will not work. Make sure you have all of them. And basically, this is already working. How do we check? With dir or ls for Mac. And you see this env folder. You can also just do it the old-fashioned way and go to your desktop and check here. What is this env folder? It has libraries, side packages. These are all the libraries that you already have installed, but I don't see the transformer library. So we'll need to install that. And if you go back here in scripts, it has the activate. So that's what we need to run in order to activate our environment. So only when we have our environment active, then we can install things inside it. I'll walk you through all the steps. Okay, let's move on. Now, we need to activate our environment. So it's there, but it's not waken up yet. So we're going to run another command, and this will be different for Mac and Windows. For Windows, you just have to type the name of your environment. For Mac, you need to say source before with a space. So this is Windows. And for Mac or Linux, is this In my case, I will type env/scripts/activate. How do you know if this works? By checking your terminal. Suddenly, before your address, there's a little env in round brackets. I'll show you. So here, it says env. That means that now I'm inside my environment. And whatever I do in my environment stays in my environment. Whatever happens in environment stays in environment. So if you install libraries in there, they're not going to be installed in all your computer, just in that folder. It's tidier. Your computer knows where to find them. You basically make a little folder for that, and you only work in that folder, so it will not overload your computer with stuff. All right, now we download. So in our environment, we want to run a pip install transformers torch. So pip is a package installer that Python uses to install libraries in your environment. Install means install. Transformers is our library. Torch is another library. It's an open source library that is developed by Python, and it basically does big math. And you need big math because the models that we're going to download, they use big math. So you press enter. Big math meaning tensors, multi-dimensional array, so arrays with many dimensions. And then it will start collecting, downloading. This takes a while. If you're on the slow Wi-Fi, it will take a slow while. Did it work for everybody? Raise hand. So this is the downloading part. Sometimes it takes a long time, sometimes it takes less. You can go for a coffee in the meantime, go get some water, hydrate yourself. It won't take too long, but I think now every one of us is downloading at the same time, so it's a little slow. But that's fine because we're in Slow AI Festival. I'll continue in 2 minutes. All right. In the meantime, we can write our script, and then when internet will happen, we can run it online. So if I go back to my page over here, these 2 lines is what I want to write. One is defining the pipeline, and it's also feeding it to a variable. A variable is just a word in this case. This instead of think of it as a box, you put values in, and then you recall it later. So pipe is this function here, and then pipe becomes the function of the prompt. So what we want to do is basically this. We have already this one, which is pipeline text generation distill bar distill GPT-2. And then we want to assign that to our variable. So this is basically our generator. So I'll say generator equal pipeline text generation. You can also say pipe, whatever. And then our generator will generate. So we can say generator, and that's our function. And inside our function, we're going to write our prompt. So I'm going to make an incomplete sentence. And when this will work, we can run it. But this will not work yet because now we're importing our library. We're running the pipeline. We're basically initiating the machine. And we're saying, now the machine is called generator. And then our generator will run this prompt. But nowhere here we can display that text. So it will generate some text, but we don't know where the text is. So we need to go back to the print function that we had before. So in here, I will say print, bind, print, and we want to print our result. So what I would do here is actually assign this to another variable, which I'm going to call result. And then here is a result. You have the generator, which is our initiation of the pipeline with this model. And then our generator will give us a result. and then we're going to print that result. This is also still not complete because we will need to tell, like, I need the text from the result, because the result is basically a package of things, including the text. We just need the text. Let's see if my still downloading. So let's give it a few minutes. In the meantime, make sure you are downloading it. Who has this downloaded already? Many hands. Okay. Who doesn't? Raise a hand. Couples. Okay, let's wait. So for the sake of this, I'm going to continue with a backup, which I called my make your own small AI. All right, now back to my code. Let me do some magic here. Open new folder. So I'm going to just open a backup folder that I had before with everything installed. I'm going to rename this demos. Okay, name.py. So again, our code is import from transformers, import, what was this, pipeline. Then we start off our machine. Our generator is pipeline text generation. And this can be also anything else. We can run text to speech from Hugging Face using the same function. So also if you have some dead time, go through Hugging Face, look at what type of tasks you can give your computer, text to speech or image description, all of these kind of things, all these like small models you can use. And our model is Listilbert/DistillGPT2. And then we want a result from the machine. So we run a prompt, which was do not forget to remember to remind yourself to. And then we want to print our result. So these 4 lines, if we run them from our terminal, I'm here in my terminal, I have my environment open, I say Python or Python 3 main.py. Actually, it did work already, but that's because it's already has the language. Yeah, so I'm running it offline now because this was already installed. But if you run it for the first time, it will start downloading the model, which is the DistillGPT2. So I'm running now 2 different tasks. In one, I'm still downloading the transformers, and in the other, I already ran the script. So if you run the script for the first time, it will start downloading your model, the DistillGPT2 model. Now, the DistillGPT2, I'm going to go back to Hugging Face. Somewhere here. If you go to the files and version, you see that the safe tensor, which is where all the weights, all the understanding of the language are saved, is just 300 megabytes. And that's way smaller than the other one that we saw before. And the DistillGPT2 is also based on GPT-2, which is the very last open model that OpenAI released. And if you go in here, files and version, this is a little bigger, 500 megabytes. Still quite small, but it has also a lot more parameters, 137 millions. So it might be slower on your computer. So for that reason, because we don't need such a big model, we're going to use this one with 88 million parameters. Now this is still downloading. So if you run your Python main.py from these 4 lines, it will give you something like this. What it says is device set to use CPU. That means that it's not using my graphics card. Normally, graphics card makes things faster, especially if you want to do many things all together, which is like reading all these tokens, all these words at once. In my case, I don't need that. I can just use my CPU. This is a 12-year-old computer, so it doesn't even work with the latest graphic drivers. And this is the text that we generated. So it says setting this pad to EOS, blah, blah, blah. And then generated text. So this is my result, right? It's kind of a list. We have generated text. And then it says, do not forget to remind yourself to remember things you don't understand, which will you not to think about them. Here I'm doing a few things, etc. So it's working. It's generating text. Doesn't really make sense yet, but we'll see how to fix that. And now it's running another one. There you go. Do not forget to remind yourself to remember this is an important lesson as it is an important lesson as it is. So what's happening is that it's repeating itself because at some point it forgets also what it already said. Yes. So what is happening here, it's you're downloading the Distill GPT-2. So that's the language model. We already downloaded the libraries. And now when you run the script for the first time, it will download the model. This only happens once because then you already have the model. I'm going to move on. I know that not for everybody this worked. That's because of many different types of errors. For those who have errors, please just stick with someone next to you. And then at the end of the workshop, I'll see everyone individually, try to see what the error is. Sometimes it's just the Wi-Fi, or if the Wi-Fi is disconnected during the download, you will have to re-download it, and that takes time. But for now, just for the sake of this workshop, let's conclude this. Who has a generation? Okay. That's kind of half people in here. That's good. Now, let's do just one task with it. I prepared many different things. Like you could run a prompt from a text file. So you could say, actually, instead of saying this, you want to say the prompt is in my text folder in this particular text file. Or you can say the prompt is online. Go look for it at www.wikipedia/whatever. So you can also do that. And that's why running a language model in combination with other Python tasks gives you actually the creative freedom to design your interfaces for your language model. So in my case, I'm just going to cat this. I'm going to create another variable. So my variable will be prompt equal, and then I'm going to copy there. And then here, I'm going to type in prompt. So now it generates a prompt, and the prompt is this. You can also update your prompt afterwards, and then run it again with a different prompt. Or you can say, actually go to my list of prompts over here, and then run every single one by one. This does the same thing we just did. But now, actually, another thing I want to do, and I have it written somewhere here, is because we get this weird parentheses thingy, we want to just clean and just have the text. We're going to make our computer speak. So we'll use a library, which is called PITTSX3, Python Text-to-Speech X3. And that's a library that makes our computer speak. It reads the text and it says it out loud. So for that, you need kind of the same thing that you have here. You need to set up the machine, the engine of your text-to-speech. You need to initialize it. And then you need to give it the text. What am I saying? And then you say, okay, now say it. So it's 3 functions. I'm going to write them down. And I have them here, actually. Two. Yeah. So this is the first one. We want to say pyttsx3.init, which stands for initialize. And I'm going to assign this to something I'll call engine. And we do it before anything else over here. And because they're both like setup functions, we're going to put them together. And then down here, this is my prompt. And the result is generating that prompt. And only after I have the prompt, I can say engine, say prompt. So this function is going to give the text the prompt to my engine, and that's what the engine is going to say. But not yet, only on my command. So only when I say engine dot run and wait, I think it's written like this. Yeah. That's also a function. Only then it will speak. So you can also give the prompt to your engine and then do other things and then come back and let it speak. So you're kind of like saving the text in the engine. So once again, we have transformers and PyTTSX3. So these are the libraries we're using. We're initializing both the text-to-speech engine and the pipeline engine. We're writing a prompt and then sending it to a generator. And then we're going to give that prompt to our engine. Yeah. So we print a result, we give it to the engine, then we let the engine talk. That's the last thing we do. Let's try this. So again, Python main.py. Again. The result. It's saying, no, sorry. Yeah, you're right. Oh my God. Thanks for correcting me. We're not saying the prompt we already know. We need to say the result. Thanks. There's another error that you're probably going to get. In the meantime, let me run it here. Main.py. Yeah, now this is going to install. But now I have it installed, but if you don't, it will ask you, what do you mean by PyTTSX3, blah. That's because it's a library. We need to install it. So back to our pip install. And then you say PyTTSX3. Make sure that every letter is correct. If you don't type the correct letter, your computer will not understand. So again, in the terminal, in the environment, the same way you did pip install transformers, you do with a text-to-speech. And so this is basically how Python works. You can add many plugins, which we call libraries. And there's plugins for virtually anything. You have text-to-speech, text generation, whatever, time. You can use packages to read the web from your computer. So there's many things that you can automate, but you still need to download those plugins. Python is just a language. I have it already installed. Who is ready to run it? Raise your hands. Okay, then let's wait a little bit. So this is my code, and I just ran the pip install PyTTSX3. And then we put it down here. Yeah. I will give you 2 minutes. Okay, yeah. So we're here. Now it's stuck on the terminal. It doesn't read it out loud. Why? And this is the conclusion of the workshop because we don't have much more time, but what is happening? So like I said before, this is not the clean text. It's just giving us this weird value, which is not text. It's a generated text. Do not forget that. So we just want this. To print this, we need to say to Python, our result is the generated text. What this is basically a list, only there is one element. It's a bit dumb, but we need to tell it we want the one element from the list. We want the element, not the list. So result, so basically result square bracket 0, square bracket, quote unquote, generated underscore text. So this is actually the clean result. I'm gonna copy paste it in my engine say. And actually, you know what I can do? I can give it to another variable and I can say clean result equal this. And then in here, instead of having this many letters, I'll just say clean result. And here, clean result. So we have our result and then we have our clean result. And then we print our clean result and we say our clean result and we give the voice to the engine. So let's see if I run this. I'm going to put it on the side so everybody can see. Right here, Python main.py. All goes well. You should hear a voice.
Do not forget to remember to remind yourself to remember all your dreams and dreams and dreams and just about everything you know. This doesn't explain everything that you can't remember that will become a reality or a permanent reality before it happens.
Yeah. So now we can still change a few things. And there's many more things that you can change. I'm just going to introduce you to the basic functions. If you go to generator prompt, after prompt, you can put a little comma and give it a maximum length. So now it's printing a whole sentence. What if I just want something short? So I don't want my computer to calculate 1,000 tokens or whatever you call it. So I'm going to say comma max underscore length equal 10. It'll be very small. Right here. And when I do that, when I run it, I'm going to run it in the background so you'll hear it. It will be just 10 words.
Do not forget to remember to remind yourself to trust.
So beautiful. Now the voice is a woman's voice. You can also change that. That's what my computer does by standard. Has its problems, but for now we're not diving into that. Another thing we can do is running it continuously. Because now it's running once, but we can do that continuously. So we need to put some of these functions inside a loop. Loop is another thing, beautiful thing you can do with coding, which allows you to just run things continuously instead of only once. So what we need is the result to be different every time. And also, of course, the clean result and all of this. So after the prompt, all of these lines, we can put them inside a loop. And this can also change every time, but for now we're keeping it the same. So we're going to run the same prompt continuously. How do I do that? Let me zoom out a bit. So there is this thing called while in Python, which says basically while something happens, this is the code that you're performing. So I just want this to run while anything. And Python doesn't understand anything. It understands true or false. It's very binary. So I'm going to say while true with a capital T, and then give it a semicolon. And then these lines, I'm going to press tab. So they're indented. They're not starting from the beginning of the line, but a bit later. You can also do one by one. You can say, this is inlined, this is inlined. And you see that they start getting color again. So what this means is that anything that is in here will just run continuously until you stop it. And because of that, we need to give it a bit of a rest every now and then. So it's good practice at the end of such a thing to give it some time to sleep. And then we need the time library again, which is import time. And in here we say time.sleep. 1 second is enough. We can also say, I want you to print every hour. So I'm going to say 3600, right? Or every year, 351, 3600, something like that. But for now, we just do 1 second. If I run this,
Do not forget to remember to remind yourself to remember.
okay,
Do not forget to remember to remind yourself to do.
another one.
Do not forget to remember to remind yourself to make. Do not forget to remember to remind yourself to leave.
I'm going to stop it. Control C. Control C, also in Max, is to interrupt the process. Now what's happening is that it's giving me just one word variation. That's because my prompt is 9 words and I'm telling it max length 10. So either I shorten the prompt or I make the max length a little bigger, like 30. I can also do other things like change the seed. So now it's choosing a random seed. But if we say use the same seed in when you do random processes, as computer doesn't understand what a random is. Like it cannot tell you a random number because they don't decide. But what we use is normally algorithms that have specific seeds, and based on the seed, the computer gives you a seemingly random value. So if we say now use seed 42 and always use seed 42, it will give you the same result. I'll demonstrate that you don't have to do it, but it's another library that you have to import from transformers, which is set seed, and then you say set seed equal 42, and that's it. And then it will just run the same prompt, the same result. And what you can do then is change the seed every hour or change the seed every generation. This is a bit useless for the sake of this workshop, but just so you know, there are many things you can customize using the Hugging Face Transformers library. So I'm going to actually remove it now. Let's see how it is with the 30 words.
Do not forget to remember to remind yourself to be patient with the patient. If you feeling overwhelmed, let refeel.
Let refeel.
Do not forget to remember to remind yourself to take up. This takes your life away, so keep it with your heart, you will. Do not forget to remember to remind yourself to ask yourself what your future holds in our lives.
Okay, so interrupted by Control C. And that's basically it. Now, I'm just going to show you what else you can do with it. But like I said before, you have functions to open text files in Python, and then you can have a list of prompts, or you can have those prompts online. Maybe you want to scrape the headlines every hour and then generate prompts based on that by, I don't know, investigating language of news media. You can change the seed. You can give it time-based task or space-based task, right? You only generate something. So you can customize the mechanics of how language models work. It's not just conversational. It can be many other things. And I'll show you how I trained my parrot. I think I have it here. This is a more complex script, but what it does, it basically goes into my gossip. And I'm not showing you my gossip, but I'm just showing you an example of it. And this is how I wrote it. It's a list of different gossips. Every gossip is an input. And in here, when I train, I take all those inputs, I give them to DistillGPT-2. So DistillGPT-2 retrains, giving more attention to those words and sentences, and also the structure of those sentences. And then it just basically puts it all together. There are also some parameters you can set here. And this takes more time. So of course, we're not doing it now. But if you want a language model using DistillGPT-2 that, if you want a bit more control over it, if you want a bit more of a style to it, then you probably want to look into fine-tuning. This is what's called fine-tuning. There are many ways of fine-tuning as well. Who doesn't have the speaking computer yet? Raise your hands. 1, 2, 3, 4, 5, 6, 7, 8. Many victims. You can stay here. I'll walk through one by one, or not. I'll publish a manual, which you'll get. I think you're all subscribed in the registration form. If not, I'll give it to AIxDESIGN, and then that will be published. And so GPT is the architecture that's developed by OpenAI, but it's not property of OpenAI. They just developed many GPTs, and GPT-2 was the last one that they released in the open. After that, they hid everything. And DistillGPT-2 is by a bunch of Hugging Face developers who took GPT-2 and then took another transformer architecture, and they trained this one, and then they evaluated it using the result of this one. So they basically give sentences to both, the result of this one, and then this has to imitate this one. So DistillGPT-2, regardless of being a very, very small language model, is still imitates the behavior and sort of mechanism of GPT-2, which is the OpenAI model. So this is not an OpenAI model. It's based on an OpenAI model. Yeah. I would say if it's not coherent, you can make the prompt larger. You can do system prompting. You have to think a bit like the computer here, because this is not conversational. It's completing sentences. So if you want it to solve a question like capital of Italy, you have to say the capital of Italy is, rather than what's the capital of Italy. You have to think a bit like a computer, and exactly like larger prompts, but then also give it larger length. Yeah, there are other ways. You can change the temperature setting. Temperature is basically how randomic or how accurate you want, or how loyal to the data set your language model is. So if you increase the temperature, you'll probably get the same result over time. If you make it a bit less temperature, more randomic, it will be more nonsensical. So now I think I have a temperature that is very nonsensical. And there are many other ways, of course, to make it more coherent. The way I did it was actually fine-tuning it. So it's giving me responses, but based on what I trained it for. And in the training, I was using already like, have you heard of, or did you hear of, and then we'll complete the sentence. And then the parrot is imitating those prompts. So I give it the prompt, did you hear that? And then it completes it based on the data set. Final question? Yes, Martina.
For now.
Yeah.
Opinion. How does it help us to choose it?
Yeah, so parameters. Okay, I knew this, but it's really difficult to explain. So it's basically the amount of weight that your language model is using. So to give you a metaphor, we had 10 people giving 10 stickers to each. That would be 100 weights, 10 times 10. So this is 88.2 millions. That's probably not accurate, but it's a way of understanding what parameters are. You can see it as the size of the model. Basically, the larger a model is, the more parameter it uses. This does not mean that it's more accurate. It just gives you a more probable answer. Yeah. But yeah, this is 88.2 millions. The DeepSeek, for comparison, was 600 billions. So of course, it's very different size and length. And that's also why this is a bit less coherent. If you use DeepSeek, of course, it gives you long results with very coherent, very loyal to, I'm an AI assistant, this is what I'm doing for you. And this is a bit of an older model. Yeah. But I would recommend just go through Hugging Face, all the text generation models that you can find, see those that are small enough that you can download, or just look at how they work, what their architecture is. It's a lot of lingo, but at the end, it's just a bunch of algorithms that give you statistical probability. And the moment you know, okay, this is the function you need to run, then that's enough for you to kind of design your own way you want to interface with the language model. Okay, so I'll be here for the next half an hour. You have a question? Okay, yeah. So nice help. Thanks everybody for joining. And see you around.